let's get started. I would like to introduce KYZEN's Regional Manager, Will Sweet.
Thank you, Sherry, and good morning, everyone. Thank you for attending for what will be a short informational session on the difference between DI water versus chemistry, and which one is right for cleaning water-soluble fluxes. We're going to start off with a little video here on the right. It's actually a mock circuit board with some water-soluble flux spread across it, and it is just DI water being flushed over top of it. So the water-soluble fluxes are designed to be at least partially dissolved in water, partially soluble in water. But is water all you need? As you continue to watch this video, you can see some of the flux, the OA flux, organic acid. I'm going to refer to that way a few times. It is the same thing as water-soluble flux. You can see it starts to dissipate, but throughout this 30-second video, it does not come all the way clean. And the reason it's also referred to as organic acids is just because it's, as opposed to being made with rosins and resins and other materials like that, it's mostly made up of organic acids like citric acid or something like that. So how clean is clean? When you're making this decision on if you're going to be using DI water or if you're going to be using chemistry in your cleaning process, you really have to define your own cleanliness standard. So while DI water is partially effective at removing these OA, these water-soluble fluxes, it's not good enough for everyone, but it actually may be good enough for you. You have to decide what your cleaning standard is. If you're making speakers for teddy bears, that you might get away with just cleaning with water. However, if you're making circuit boards that go into fighter jet planes or something like that, you may need a little bit higher reliability behind your products, and you may have to add chemistry in that process. There are positives to DI water for sure. The cost, you're not having to add any other products to this cleaning process. It's just simply the water that is going through your pipes right now becoming deionized already. So that is the only cost that you have so far. Also the green perspective. This is water. Also, I mean, putting anything down to drain is always up to your local POTW, but we've seen several people, most people are able to just put DI water after the cleaning process down the drain. And then of course it's very simple. The simplicity of DI water, you don't have to worry, you don't have to check concentrations, you don't have to add any more chemical, you don't have to add makeup to make sure that the concentration stays consistent. And yeah, it's just a few less things that you have to do when you're using DI water only. Of course, everything comes with negatives. When it comes to DI water, it actually has poor solvency for many commonly seen molecules in fluxes, not just the rosins and the resins. But DI water, I guess you should say, was not specifically designed to clean flux. Really, the water-soluble flux was designed to be cleaned with DI water. So it's a little bit backwards in that way. There's also poor wetting. And what I'll get into a little bit in more detail on the next slide, DI water has high surface tension that causes a problem with some of the more low standoff components of today. So yes, water makes large droplets. Speaking to the surface tension, DI water has about 74 dynes per centimeter. While adding a small concentration of chemistry, so an aqueous bath has less than 30 dynes per centimeter. And then at the bottom of the screen in this little infographic, the substrate is just the bottom of the circuit board. And then we're going to have two little components right here to signify how high up off the bottom that they are. Component 1 is a 3+ mil gap, which in the past was commonplace, a fairly high component. And component 2, we've become all too familiar with less than 2 mil gaps in today's kind of technology. And then as you see this DI water droplet come in, it's supposed to signify the 74 dynes per centimeter. And in the past, it had no issue getting underneath component 1, the components with 3+ mil gaps. But it physically will not fit under the smaller components of today that are less than 2 mil in gap. And then now you can see the Aquinox, which is the aqueous bath droplet. Aquinox is just one of our product lines, lowering the surface tension to less than 30 dynes per centimeter. With that, it is actually able to fit underneath the less than 2 mil gap to get in and get out and remove flux with it. So lowering surface tension is not the only thing chemistry allows you to do. Of course, now with chemistry added to the bath, you're able to get in and out of those low standoffs, bringing the flux with it. But anyone who's ever used water-soluble fluxes has probably seen foam a time or 2 or 12. So these water-soluble fluxes are notorious foamers. So in the wash, whenever it's introduced with just water, worst case, it can start to foam. The foam can then leave the bath and get all over the workshop floor, and that's going to halt production, and that hurts everyone. That loses money. Bringing just a small amount of chemistry into the bath with it actually brings in defoamers as well. So whenever the foam is starting to generate from these water-soluble fluxes, this defoaming action will actually halt the foam generation, and it will start to dissipate. We also have another Tech-to-Tech by Eric Miller, who actually goes into much more detail about foaming in your process. So feel free to look at our website to find Eric Miller's if you want to get more into this idea in particular. Also, chemistry allows you to have a longer bath life in between changeouts. And what that means is it takes longer for the bath to become saturated with the flux residue. There's more in there. The chemistry actually counteracts the acidity of the fluxes. And say you have to change your bath out every 2 weeks when you're using just DI water. Adding a small amount of chemistry, it wouldn't surprise me if that added a week or 2 onto that before you had to change out the bath to continue cleaning your product. And then, of course, you get improved flux solubility. These chemicals are specifically designed to remove these flux residues. So that combined with the DI water, which the flux is supposed to be soluble in already, it just makes cleaning much easier and much quicker. And that brings me to throughput. If you're able to clean this product faster with chemistry added, then you're going to be able to clean more products. You're going to be able to clean it for cheaper and get more products out the door. And that brings me to this direct comparison. The video on the left is the one that you've already seen. Both of these videos are about 30 seconds long. The one on the right is with only 3% chemistry added. And you can already see that that board, the mock circuit board with the water-soluble flux on it, is being cleaned much quicker and much more thoroughly with just a small amount of chemistry added to the bath. So all in all, is DI water good enough? The first step is knowing exactly what clean means to you. So maybe cleaning with DI water is good enough for you and you don't need chemistry, but really it matters. It's up to you and your customer standards. If there's no issues with your customers, if there's no shorts in your product after they receive them, then you may not need chemistry. But it all matters what it's up to your customer and up to your cleanliness standard. Overall, chemistry is going to improve your overall cleanliness. It's going to improve your rinsability, your bath life, your productivity since you will be able to clean parts faster, and potential foaming as well. And I think the biggest distinction of all of this is to know that water literally cannot reach under those low standoff components, the less than 2 mil gaps. This water is going to lower the surface tension of the entire makeup and actually allow you to get in and out of those low standoff components, bringing the flux with it. And then I'm going to turn this over to Sherry for any questions.
Thanks, Will. Great job. If you would like to discuss this topic further, please contact your local KYZEN regional manager or send an email to tech@kaizen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.